students, welcome back to PU2 Brahmastra series, and in today's video we are going to discuss the most important questions from the chapter Aldehydes, Ketones and Carboxylic Acid. Now let me tell you that this chapter among all the organic chemistry chapters has the highest weightage. Okay, so if you prepare this chapter thoroughly, then easily 10 marks you can secure in the section D, that is the 5 marker sections, because from this chapter you are getting more number of 5 marker questions. So let us first I'll tell you, just if you watch this video and solve all these questions, then you will be very close to getting full marks in this particular chapter. Okay, so let's first discuss the mark distribution for this chapter. So it has a weightage of 12 marks in your final board exams. You can see 12 marks. And how is this 12 marks distributed? So you will have two marker questions, that gives you 10 marks, and there will be 2 MCQ questions. Okay, so now let us start with the MCQ part. Okay, so I have collected all the hot question for all of you, and we will be solving these questions. Okay, so let us see the first question. An organic compound X gives a red precipitate on heating with Fehling solution. Which one of the following reaction yields X as a major product? Now if it gives Fehling's test, then we know that X must be what? It can be either, can it be ketone? No. If it is giving Fehling's test, then it has to be an aldehyde group. So we have to find that reaction where we can actually create or we can actually produce aldehydes. Now in this already aldehyde is there, so that one will not give me reaction. Next, if I have this one, that is AgOH, okay, it is also not giving me aldehydes. Ag2O will also not give me aldehydes. Now C2H2O with H2O with H2SO4 HgSO4, if you have this combination CH, okay, C2H2 is this one. Okay, now when you treat it with water, okay, so first of all what happens on addition of water in presence of Hg2 plus, okay, there is H and OH is added, okay, you have double bond. So now what will happen, this will undergo, this lone pair will come here and this one will come here, and you will get HC double bond O and we have CH3. Okay, so this is your ethanol or the aldehyde formed. So that is why correct answer here is option number D. Okay, next question, find the final product D in the given reaction. Okay, so first of all Br2 and FeBr3 is there, so that will be the addition of bromine. So here you will have bromine added. Okay, then you have Mg ether, so here what will happen, Mg will be added. Okay, this is plus and this is minus. Now in case of dry ice, means you have solid carbon dioxide, right? So this negative one will attack here, this bond will come here, this one will go here, and that will take a H. So here what I will get, this is nothing but benzoic acid. Next you are treating with concentrated HNO3 and H2SO4, that is what nitration happens. So since this COOH is a electron withdrawing group, so it is a meta-directing group. So this is a meta-directing group. So if it is a meta-directing group, in that case what will happen, nitration will take place at meta position. Okay, so what I will get here, D will be, you will have COOH and NO2 group. Okay, so you can see which is the meta position. So first of all here you can see there is so many NO2 groups with OH, this cannot be the answer. Here we have COH but 3 NO2 groups will not be there. Here we have meta nitration but OH group is there, that is why this is wrong. This is the correct answer, that is option number D here. Okay, next question is called as, so this, when do we get this compound? See, when you have C double bond O, okay, and you react it with HCN. So what will happen, CN is a nucleophile, it will attack on this one and this one will go here, and you will get a compound like this. Okay, and this compound name is, which is asked in the question, is cyanohydrine. Okay, so that is option number C here. Next question, a compound does not react with 2,4-dinitrophenyl hydrogen. The compound is, now see, the reaction with 2,4-dinitrophenyl hydrogen is the property of aldehydes and ketones. Okay, so acetone is a ketone, Acetone is a ketone, so it will react. Acetaldehyde is a aldehyde, so that one will also react. This is also a ketone, this will also react. Here this is an alcohol, so it will not react with this one. So option number C is the correct answer. Next we have the end product in the following reaction. So first of all we have ethyne, then we are having Hg2 plus and H2SO4 addition here. So here what we will have, CH double bond CH, and then we have OH and H. Okay, now after this will undergo tautomerization. That will happen, double bond O will come here and this one will come here. So I will have the product, that is CH3C double bond OH. Okay, this product is A. Now what will happen, we will add CH3MgX to this one. Okay, now when you add CH3MgX to this one, so that is like this. Okay, plus and minus. So this one will attack on this one will go here. So you will get CH3C, and then you have CH3, and then you have OMgX. Okay, clear? Now after that what happens, here we have is, now after that this will undergo hydrolysis and you will get CH3OHCH3. Okay, so this is the first one is A, and then this is your B. Now B is undergoing oxidation. So if this one undergoes oxidation, it is a secondary alcohol. So secondary alcohol on oxidation will give you CH3 C double bond OCH3. Okay, which is C, acetone. So that is option number C here. Next question, the major product in the following reaction is, so we have COOH, COH and NH3 is there. Okay, so what happens in this particular reaction? First there is amide formation. Okay, so first step what happens, we get a compound like this. You have C double bond O NH2, and then you have C double bond O NH2. Okay, now in this NH2 and NH2 there is a loss of ammonia. Okay, so if ammonia is lost from here, what I will get, NH3 will be removed and you will get a compound like this, C double bond O NH double bond O NH. Okay, now this compound is this one. Is it this one? No, here the aromaticity is not completed, here it is not there. Okay, okay, I think this one is having error. Yeah, this has to be the answer. Okay, this has to be the correct answer, that is option number C here. Okay, next we'll move to question number 7. What is the IUPAC name of the organic compound formed in the reaction? Okay, you have to find the product's name. So first there is acetone. Okay, you have acetone. Okay, I have this reactant, then you are reacting it with C2H5MgBr dry ether, C2H5MgBr, and we have dry ether. Okay, and you have H2O and H plus, right? This is the reaction that we are having. Now in this case, if you see, this is plus, this is minus, right? So this one will attack here and this one will attack here. So what I will get, CH3COH, okay, CH3, and I have C2H5. Clear? So what is the name of this compound? It will be 1, 2, 3, 4, right? So 2-methyl butane 2-OL. Okay, so that is option number D, 2-methyl butane 2-OL. Next question is, match the following with the name reactions. Okay, so you have COHCl with anhydrous AlCl3 to benzene ring. So that is your preparation of aldehydes, Gattermann-Koch reaction. So A has to be option number 2. Okay, so there is only one option with that, option number D. So I am correcting that directly. Let's see the other thing. Then we have B, RCOCH3 plus NaOX. This is haloform reaction because you have this COCH3 group. So B has to be 3. Yes, that is also correct. Next, you are reacting an alcohol with an acid. So that is your esterification reaction. So C has to be 4. Then you have this RCH2COOH with X2 and red phosphorus. So that is your Helmholtz HVZ reaction where this alpha hydrogen will be replaced with the X group. So D will be 1. Okay, that is this one. Clear? Next we'll see question number 9. An organic compound X on treatment with acidified K2Cr2O7 gives compound Y which reacts with I2 and sodium carbonate to form triiodomethane. The compound X can be, okay? So you have an organic compound X on treatment with K2Cr2O7. So we have X, and when you treat it with K2Cr2O7, okay, it gives you compound Y. Okay. Now this compound Y reacts with I2 and sodium carbonate. Reacts with I2 and sodium carbonate. Okay. I2 and sodium carbonate to form triiodomethane. Okay. To form you triiodomethane. Okay. The compound X can be. Now see here, if I want this compound to react with I2 Na2CO3 and then it is giving me this CHI3, this compound must contain CH3CO group. Okay, and this is an oxidizing agent. Okay, that means after oxidation I am getting either an aldehyde, ketone, something. So that indicates that X has to be an alcohol first of all. Okay, an alcohol which on oxidation is having this methyl ketone group. Okay, so which alcohol can it be? If I have CH3CHO, then I won't get this group. It cannot be a aldehyde from before. Okay, if I have this compound, here also it is ketone, I cannot have a ketone because X has to be an alcohol. Now if you see this one, CH3CHOH-CH3, if X is this one, okay, then if this is Y, if this is X, so on treatment with K2Cr2O7, what I will get? I will get CH3, C double bond O, CH3, which is Y, right? Now here if you see this particular compound is there, and with I2 and Na2, so there are NaOH, this has methyl ketone group, so you will get this CHI3 here. So that is why answer has to be option number D here. Okay. Next question number 10, Z in the following reaction is, okay. So if you see Z in the following reaction, if you have cold dilute alkaline KMnO4 and if that is heated, okay, when that is heated, you have here cyclo, so this group breaks and converts into acid, so you have cyclohexane carboxylic acid, okay, option number, so this is actually C and D. Clear? Okay, now let's do next question. Major product when benzoic acid is heated with ammonia. So that will get benzamide. Okay, so there is not like you have benzoic acid. Okay, and when it is treated with ammonia, okay, so this OH group is replaced with NH2 group and you will get benzamide. Okay, that is option number B here. Next, the reagent used to convert carbonyl compounds to hydrocarbon is. So this is your reduction of carbonyl compounds directly to hydrocarbons. Here we have two reactions, Wolff-Kishner and Clemmensen reduction, right? So we have zinc amalgam is used in Clemmensen reduction, whereas in Wolff-Kishner we have hydrazine and ethylene glycol. So option number C here. Next, in Stephan reaction, alcohols are converted to aldehydes, or carboxylic acids are converted to aldehydes, nitriles are converted to aldehydes, or haloalkanes are converted to aldehydes. So it is the reaction of nitriles, that is CN, cyano group is converted. So Stephan reaction, option number C here. Next, aldehydes which answers Cannizzaro reaction does not contain. So Cannizzaro reaction is a reaction where the compound undergoes disproportionation reaction, means it gets oxidized and reduced. So the alcohols will oxidize to salts of carboxylic acid and will get reduced to alcohol. So such reactions are called as Cannizzaro reaction, and in this reaction you should not have any alpha hydrogen. Okay, so that is why option number C. Next question, oxidizing agent used in Itard reaction is CrO2Cl2 direct. Name reaction question, this one. Okay, so with this the 1 markers are over, and in this chapter we have only 5 marker questions, so I am not discussing any 2 marker 3 marker questions here. We'll be directly jumping to 5 marker questions. Okay, so let us start with the first question. How would you prepare aldehydes from acetyl chloride or benzoyl chloride. Okay, so if you remember, if you have this acetyl chloride or benzoyl chloride, we have a reaction that is called as Rosenmond reaction, and Rosenmond reaction converts this acyl chlorides to aldehydes. So we will use the reaction here, that one, and the reagent here used is H2 palladium barium sulfate. Okay, I'll show you the answer also. How do you prepare aldehydes from nitriles? So just now we have solved in the MCQ by using Stephan reaction. Okay, next we have name the reagent or oxidizing agent used in Itard reaction. It is your CrO2 Cl2. Okay, so first of all, A, acid chlorides on reduction with H2 in presence of palladium catalyst and barium sulfate gives aldehyde, and this is your Rosenmond reaction. Okay, so you can see the reaction. You have benzoyl chloride with hydrogen, palladium, barium sulfate. Chlorine is replaced with hydrogen. Okay. Next question, how to prepare from nitriles. Okay, so you can see nitriles on reduction with stannous chloride, that is SnCl2, and hydrochloric acid gives imine, that is this one. This is your imine formed. Okay, which on hydrolysis gives corresponding aldehyde. This reaction is called as Stephan reaction. Next we have name the reagent that is used in Itard reaction. So that is your CrO2 Cl2. Clear? Okay, next question is what is Itard reaction? Explain. How would you convert toluene into benzaldehyde by using chromic oxide or chromic anhydride? Next, carbon group is more susceptible to the attack of nucleophile. Justify your answer. Okay, now you see this one. What is Itard reaction? So in Itard reaction, we take simple benzene, okay, toluene on oxidation with chromyl chloride, that is CrO2Cl2, gives chromium complex, okay, and which on further hydrolysis gives you benzaldehyde. So you can see the reaction. You have taken this toluene with CrO2Cl2 and CS2, we get this chromium complex, and this chromium complex on hydrolysis gives you benzaldehyde. So this is your Itard reaction. Next, how do you convert toluene into benzaldehyde? By using chromic oxide. So toluene also reacts with acetic anhydride and chromic oxide to give you benzylidene acetate, which on acid hydrolysis gives you benzaldehyde. So here you have taken toluene, CrO3 and acetic anhydride. Here we get this particular intermediate which on hydrolysis gives us benzaldehyde. Next question is carbonyl group is more susceptible to the attack of nucleophiles. Justify your answer. Now see, in carbonyl group, if you see, the structure is like this. Okay, oxygen is electronegative, carbon is electropositive. Since it is electrophilic in nature, so that is why the nucleophiles will attack on the carbon here. Okay, so because oxygen is more electronegative than carbon, the carbonyl carbon acquires a partial positive charge, so it is attacked by nucleophiles. Okay, next question, explain the commercial method for the for manufacturing benzaldehyde by side chain chlorination of toluene. Explain the Gattermann-Koch reaction, and how do you prepare aldehydes from esters? Give an example. Okay, so these all three questions are based on the preparation of aldehydes. The first one is explain the commercial method of benzaldehyde side chain chlorination. So chlorination of side chain of toluene gives benzyl chloride. This name is important, please remember, which on hydrolysis gives you benzaldehyde. So if you see, first of all, CH3 is there. If you do side chain chlorination, you will get here actually CHCl2. After that, when you treat it with water, all this Cl group is converted to, so you will get a compound like this. You have CH, OH and OH, and then with benzaldehyde you will get CHO, okay, on further hydrolysis. So yeah, that's the first question. Next, explain Gattermann-Koch reaction. So for Gattermann-Koch reaction, we have benzene reacts with carbon monoxide. Okay, benzene reacts with carbon monoxide and hydrogen chloride in the presence of anhydrous AlCl3 and traces of cuprous chloride to give you benzaldehyde. Okay, so how does this reaction takes place? So you have benzene COHCl and then anhydrous AlCl3 with copper chloride, that gives you CHO or benzaldehyde. Next you have how would you prepare aldehydes from esters. So esters, if you directly treat them with dibyl H and water, then you will get this acetyl, you will get aldehydes. Okay, you can see this whole esters gets converted to aldehyde. Clear? Let's move to next question. Aldehydes generally are more reactive to ketones for nucleophilic addition reactions. Give reason. Benzaldehyde is less reactive towards nucleophilic substitution addition reaction. Give reason. And higher ketones like acetophenone does not react with NaHSO3. Give reason. Okay. Now see here. So first of all, aldehydes are generally more reactive than ketones. There are two reasons for this one. Okay. So this itself carries 2 marks. Now what are the 2 reasons? So you know, aldehydes, the carbon, as we have discussed, is electrophilic in nature, right? If you see the structure of aldehydes, it is like this, right? This carbon is electrophilic. That means nucleophile can come and attack on this carbon. But if the R groups present here, in ketones there are 2 R groups, right? And what is the role of R group? They have plus I effect. They will donate electrons here. Now, if they donate electrons, the carbon nucleophilicity decreases, right? Sorry, electrophilicity decreases, and that is why the reaction of nucleophile decreases. That's the first thing. And the second is, when you have this much big R groups, okay, it provides steric hindrance to the incoming nucleophile. So that is why also the reaction is slower here. So how we will write this one? So the first thing is your steric effect, and the second one is electronic effect. These 2 points are given in NCERT book, so you have to explain it. And as I have told you, in steric effect, the 2 R groups of ketone provide steric hindrance to the incoming nucleophile. And in electronic effect, the 2 R groups in ketone reduces the electrophilicity of carbon because of their plus I effect. Okay, these are the 2 reasons. Next, benzaldehyde is less reactive towards nucleophilic addition. Give a reason. So benzaldehyde, CHO, is an electron withdrawing group. Okay, if it is an electron withdrawing group, then definitely, okay, benzaldehyde is to the nucleophile. So benzaldehyde, again you can see there is a very big group is attached. So if you see why benzaldehyde is less reactive, see, this is there, right? Now what happens, this ring, this is in resonance with this one, so this one reduces the electrophilicity of the carbon. Okay, this one reduces the electrophilicity of the carbon through resonance, because of which nucleophilic addition is again decreased here. Okay, so how we can write then? Due to the resonance, the polarity of the C in CO is reduced. Next, higher ketones like acetophenone does not react with NaHSO3. They do not react because the ketone group, the higher ketones have a lot of steric hindrance, so addition reaction is reduced to a greater extent here. Okay. Moving to the next question, what is Clemmensen reduction? Give an example. Wolff-Kissner reaction, give an example. Name the reagent used to the characterization of aldehydes and ketones. Okay, so first of all, Clemmensen reaction, reductions of aldehydes and ketones in presence of Zn, Hg and HCl. Okay, and then you have what is Wolff-Kissner reduction? So I'll just give you the example of one reaction here. Suppose CH3COH is there, and if you just treat it with zinc, amalgam, HCl, okay, then this one will be reduced to CH3CH3. Okay, next, reductions of aldehydes and ketones in presence of NH2, NH2 ethylene glycol and KOH. So here if you have CH3COH, and then if you are reacting it with NH2, that is your ethylene glycol, that will give me CH3CH3. Okay. Next, name the reagent used for the characterization of aldehydes and ketones. So 2,4-DNP is used. So this is, if 2,4-DNP is reacting, then we conclude that the compound has either an aldehyde or a ketone group. That you might have also studied in the biomolecules chapter. Okay. Next, we'll see question number 6. Explain the test to distinguish between aldehydes and ketones. Aromatic aldehydes do not answer to Felling's solutions test. Okay. Now, you can use here Tollens reagent or Felling's reagent. Both of them will react with aldehydes but not with ketones. And and the special case about the aromatic aldehydes, Felling's solution will only react with aliphatic aldehydes and not aromatic aldehydes. What is the reason for that? That is the second part of the question. So let us see the first one. Tollens test, we can use aldehydes on reacting with Tollens reagent, gives a bright silver mirror, which due to the formation of Ag. You can see this reaction. I am getting a bit your side. You can see you have RCHO with AgNH3 whole 2 plus and 3OH minus. That gives you RCO minus plus Ag plus H2O plus 4NH3. Next we have aromatic aldehydes undergo Cannizzaro reaction due to the presence of alpha H in the presence of alkali medium. So when there is aromatic aldehydes are there, right, they do not undergo this Felling's reaction because of this because if you know, the Felling solution provides you alkaline medium, okay, and in that what happens, this molecule, this compound or this reactant undergoes Cannizzaro reaction and not the Felling's test, okay. Next question, what is haloform reaction? Given example is isopropyl alcohol undergo haloform reaction, okay. So haloform reaction is when you have methyl ketone, CH3CO group if it is present, then the molecule gets oxidized to give you salt and sodium salt of carboxylic acid and iodoform or haloform, okay. So aldehydes and ketones with at least one methyl keto group. Now what is this methyl keto group? This one. Okay, this is your methyl keto group, are oxidized by sodium hypohalite. Sodium hypohalite is what? NaOX. Okay, this is sodium hypohalite. To sodium salt of carboxylic acid and one carbon less than the parent carbon. So I'll give you one example here. Okay, so for example, if you have CH3CO CH2CH3, okay. Now this one, if it is reacting with NaOI, then what will happen? This bond will break here, okay, and sorry, not here, 1 second, sorry, yeah. So this bond will break here, okay, and this one will get converted to CHI3, okay, and this one will be from sodium salt. You will get CH3 CH2 COO minus Na plus. Clear? Okay, next we have is isopropyl alcohol will undergo haloform reaction. Okay, isopropyl alcohol will undergo haloform reaction or not. So if you see, isopropyl alcohol structure is CH3 CHOH CH3. Okay, this compound is there, so this one will definitely undergo your haloform reaction. So that is why this one will be the because we have the CH3 CHOH group, so yes, this one will undergo haloform reaction. Next question, what is aldol condensation and give an example. So first of all, aldehydes and ketones, okay, when you have one alpha hydrogen, okay, can undergo self-condensation in presence of dilute alkali to form beta-hydroxy aldehydes or ketones. And this aldol formed undergoes elimination reaction or dehydration to form alpha-beta unsaturated aldehydes or ketones. And this reaction is called as aldol condensation. Now there is a question to give an example. So let us understand one example in detail. Okay. So first of all, I'll take for example CH3COH. Okay, now you can see this is the carbon containing the functional group. So the hydrogen present here is called as alpha hydrogen. Now when you have a dilute like any dilute NaOH for example, so what will happen, OH will abstract this hydrogen, okay, and we will get a compound like this CH2 minus C double bond OH. Okay, this is step 1. Now after that what happens, you have this CH, so there's another molecule of this CH3COH and then it reacts with CH2COH. Okay, minus is there. Now this minus will attack on this one and this bond will come here. So what I will get here, CH3CO, okay, and then you have H here, okay, and then this C is attacking here, right? So this one will joined here, CH2COH, okay. Now after this, so this O minus is formed, then it will get converted to OH and this product is called as aldol condensation. Now what you can see, if you have the CH2H, CHOH, okay, you have CH, I'll write like this, yeah, C H and then H, and then we have C double bond OH. Okay. Now when you heat it, okay, when you provide heat, there is dehydration reaction, and remember this dehydration reaction occurs in the the Seitzef rule method. Okay, so you can have OH and H can be eliminated from here, aldol alkene can form here also, alkene can form here also, but according to the Seitzef rule, the more stable alkene or more substituted alkene is stable, so that is why here we will have double bond. So what will be the product formed here? CH3, then you have a CH double bond CH, and then we have C double bond OH. Okay, now this one is called as what? Now see, this particular compound, if you see, this is alpha beta. Okay, alpha beta unsaturated compound. Okay, because you have double bond here, so this is called as alpha beta unsaturated compound. Okay, so that is why this will be called as aldol condensation. You can write down this particular example. Okay, so any aldehydes or ketones which have one alpha hydrogen will undergo this reaction. Now let's see the next question. What is Cannizzaro reaction? Give an example. Which type of aldehydes undergo Cannizzaro reaction, and why acetaldehyde does not undergo Cannizzaro reaction? Okay, so first of all, what is Cannizzaro reaction? Two molecules of aldehydes which do not contain any alpha hydrogen. Okay, please remember here, in case of Cannizzaro reaction, it does not contain alpha hydrogen, reacts with strong alkali and undergo redox reaction to produce a primary alcohol and a salt of carboxylic acid. This reaction is called as Cannizzaro reaction. Okay, next question, I'll give you an example here for Cannizzaro reaction. So for example, if you have formaldehyde, okay, with I can write with concentrated H2SO4. Okay, with concentrated H2SO4, what will happen? This one will undergo oxidation and it will undergo reduction. So you have HC double bond O, O minus, Na plus. Okay, this is what? This is the oxidized product, and it can also undergo reduction. You will get HCH2OH. Okay, so one is your oxidized product and another is your reduced product. So this reaction, and you can see this compound has no alpha hydrogen. Okay, so that is your Cannizzaro reaction. Next, which type of aldehydes undergo Cannizzaro reaction? Which has no alpha hydrogen. Next, why acetaldehyde does not undergo Cannizzaro reaction? So if you see the structure of acetaldehyde, it is like this, right? So it has an alpha hydrogen, right? It has an alpha hydrogen, so that is why it will not undergo Cannizzaro reaction. So I can write because it has alpha hydrogen. Clear? Okay. Next question, how would you prepare carboxylic acid from primary alcohols? Explain with an example. Next, how do you prepare carboxylic acid from nitriles? And how do you prepare carboxylic acid from Grignard reagent? Explain with an example. Now you can see this question has been repeated, and this is the important question. So first of all, if I see the preparation from primary alcohols, so you can simply use any strong carboxylic acid can be prepared from primary alcohols by using any strong oxidizing agents like KMnO4 or K2Cr2O7. Now if I give an example here, if I take CH3OH and if I react it with KMnO4, then I will get HCOOH. Okay. Next is how can you prepare carboxylic acids from nitriles? So nitriles are hydrolyzed to amides and then to acids in the presence of H plus or OH minus. Here also if I have an example, right, CH3CN if you take, and if you just add H3O plus, you will get CH3COOH. Okay. Now next one, how do you prepare from a Grignard reagent? So Grignard reagent reacts with solid carbon dioxide, that is dry ice, to form salts of carboxylic acid, which on hydrolysis gives you acid. Okay. Now I'll give you an example for this one also. Yeah. Okay. So if I have this Grignard reagent, so for example CH3MgBr is there. Okay. Then it is reacting with carbon dioxide. This is plus, this is minus, this one is attacking here, this one is attacking here, this one comes here. So I'll get here, I'll just get down and write here CH3, right, C double bond O, then you have OMgBr. Okay, and after that if you do hydrolysis, what I will get here? CH3COOH. Okay, so that is the reaction with carbon dioxide. Next question, how do you convert acetic acid to acetamide, and how do you convert phthalic acid to phthalimide? Give equation. So first of all, how do you convert acetic acid to acetamide for option A, like question number A? So if you just take acetic acid, okay, and react it with ammonia, then you will get acetamide. Okay, now converting to the continuing with the second question. So if you have acid group with ammonia, you will get here CONH4 and this one. Then with dehydration you will get amides, and then with strong heating ammonia will be released and you will get phthalimide. Okay. Next question, what is decarboxylation reaction? Give an example. Name the product formed when sodium acetate is heated with soda, lime, and name the reaction. Name one decarboxylating agent. Okay, so what is decarboxylation reaction? The process of removal of carbon dioxide from the sodium salt of carboxylic acid. So for answers I have used certain shortcuts that you don't have to use. You have to write the full word. Due to space constraint I have used, but you write the full word. Okay, the carboxylic acid using dry soda lime is called decarboxylation. Give one example. Okay, so you can see RCOO minus, if you treat it with NaOH and CO and heat, so here CO2 will be removed, you will get RH plus Na2CO3. Next, name the product formed when sodium acetate is heated with soda lime and name the reaction. So if I have this one, sodium acetate, that is CH3COO minus Na plus, okay, is heated with soda lime, that is NaOH plus CaO, okay, soda lime, then it will remove this CO2 group and you will get CH4, okay, and name this reaction. So name reaction, you know, decarboxylation reaction. So CH4 plus Na2CO3. Okay, now the next is name one decarboxylating agent. So the decarboxylating agent is your soda lime. Clear? Okay, next see the next question. What is HVZ reaction or Haloform-Zelinsky reaction? This is a very important name reaction. Give an example. Explain the nitration of benzoic acid with equation and explain the bromination of benzoic acid with equation. So what is HVZ reaction? Carboxylic acid containing alpha. So let me just give a disclaimer here. What is Ca? Okay, I am writing wherever I am using Ca, it stands for carboxylic acid. Okay, fine. Carboxylic acid containing alpha hydrogen reacts with chlorine or bromine in presence of small quantities of red phosphorus to form alpha halo acids. So you can see RCH2COOH, right? This is the alpha carbon and the hydrogen attached to it is alpha hydrogen. Now when you react with X2 red phosphorus with water, this hydrogen is replaced with X. Now this is the alpha carbon and here we have the halogen, so it is alpha halo acid is produced here. Okay, next we have explain the nitration of benzoic acid. Now if you see first one, that is nitration of benzoic acid. Okay, so nitration. So I have concentrated HNO3 and I have concentrated H2SO4. Okay, now see, nitration means what? COH group is a electron withdrawing group. Okay, it is a electron withdrawing group. So that's why if this is an electron withdrawing group, then nitration will take place at the meta position. So what I will get here? You will get this compound. Okay, next question is explain the bromination of benzoic acid. So I'll just use the same one here. So if you use Br2 with FeBr3, so that will do bromination in the ring, and again the bromination will take place at the meta position. So I'll get COOH and I'll get Br here. Clear? Okay, next let's do a word problem type question. An organic compound A, okay, with molecular formula C8H16 and O2 was so let me just write down this one what we have studied here. So it is C8H16O2. Okay, was hydrolyzed with dilute sulfuric acid to give a carboxylic acid. It was hydrolyzed, okay, was hydrolyzed with dilute sulfuric acid to give a carboxylic acid B. Okay, this is carboxylic acid. Carboxylic acid B. Okay. Next, and an alcohol C. We have an alcohol C here. Okay. Next, oxidation of C with chromic acid produced B. So, if I have oxidation of C with chromic acid produced chromic acid, right? So, that is, sorry, chromic acid is, okay, so it is a strong oxidizing agent. Okay, so that will give me, chromic acid will give me this one, B. Okay. Now, the compound C on dehydration gives but1 ENE. Okay, compound C on dehydration means minus water gives me but1 ENE. Okay. Okay, next, write the equations for the reactions involved here. Okay, so first let us try to identify the product. Now, this is an alcohol, and on oxidation you are getting this carboxylic acid. So, that clearly indicates that this alcohol must be a primary alcohol. Okay. And next clue that we have is removal of water is giving me but1 ENE. So, that means what must be this alcohol? This alcohol must be CH3, CH2, CH2, CH2OH. Okay. So, this is butane 1OL. Okay. And you need to have one carboxylic acid, one alcohol. So, this must be what then? When you undergo hydrolysis, you are getting an acid and an alcohol. That indicates that this must be one ester. Right, 8 carbons are there, and you are, if on oxidation we are getting this one, means this will have 4 carbon, this one will have 4 carbon. So, easily I can guess that this particular A is nothing but CH3, CH2, CH2, then I have C double bond O, O, CH2, 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 CH3. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 carbons are there, 2 oxygens are there, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 3, 16. Total number of this one is also there. That is number of oxygen, hydrogen, carbon is satisfied. So, this is my compound A. Okay. Now, when it undergoes this one, that is hydrolysis, what I will get? You will get one side oxygen. One side you will get CH3, CH2, CH2, C double bond OH, and another product that I will get is alcohol, that is CH3, CH2, CH2, OH. Okay, so this is carboxylic acid is B and alcohols is C. Okay, next C, this one on dehydration. Okay, so if you have C on dehydration, you will get but1 ENE. Okay, that is D. Clear? Getting this one? Okay. Next is, we'll discuss the most important topics from this chapter, so you must not miss these topics. Okay, the first one is the name reactions. There are a lot of name reactions in this chapter: Rosenbaum reaction, Stefan reaction, Itard reaction, Clemmensen reduction, Wolff-Kissner reduction, aldol reaction, Cannizzaro, HVZ, decarboxylation, Tollens reagent, Fellings reagent. So these all name reactions you should remember. Then mechanisms is, we have nucleophilic addition of nucleophilic addition reaction, then aldol condensation and formation of acetal and hemiacetal. Okay, so with all these things we are done with this chapter. Please first prepare these questions, prepare these reaction mechanisms, name reactions, then go for further questions. Okay, thank you so much, and I hope this session was helpful. If you have any doubt, please put down your doubts in the comment section. We'll definitely address to it. And thank you so much, and just for all your love and support, and stay tuned for the next session.